All right, welcome to DOM Calculator Review and Refactor. So this is Carl's solution. Thank you, Carl, for donating this. And I'm going to talk you through how I would approach refactoring this. So this is just demonstrated. Looks like it works okay. Do that, plus 6. I can't do more than one operator in a row. Can't change the operator, but that's fine. Those are the requirements. And then, cool. So let's take a look at how Carl did it. So we have all of the element selectors in one place. I like that. Using the I'm not sure if I like this though. You're doing get element by ID and then query selector and then elements by class name and then element by ID and then element by ID. Probably just use query selector for all of that.
Using buttons div as well. Like after that, those aren't used. So
oh, interesting. So let's see.
I've got one button delegation, basically.
Oh, interesting. Okay, so one of our goals is going to be to get as much like of this switch shit out. So ifs and switches are like probably the biggest diseases that we get in our code. It's and I gave a talk once upon a time. Look up slides.com/Kyle Coberly called Programming Without Ifs. It's like one of the very first things you learn as a programmer. It should probably be one of the first things you kind of forget too. So like the reason that we don't want those ifs is a thing called cyclomatic complexity. Cyclomatic complexity is how many different independent paths there are through your code. And the more of them you have, the more places your code can break. So as an example, if I have an if statement where I have some condition, even if I don't have the else on there, I have two paths to the code. I have the one where the condition matches, and then we keep going, or I have the one where it never does any of those at all. So if there's some kind of state change that happens in here, something like that, I need to write two different tests. One for, all right, that happened, or one for that didn't happen. And it's not always that easy to figure out how many different paths there are. Ifs make them, but also, let's see. Any of these, if, else, else if, case, catch, any kind of Boolean operator, ternaries, all of those cause cyclomatic complexity. So more tests, more points of failure, harder to extend. Because those different cases, I think I have an example coming up here, like this, where you look at all the ifs in this. It's very difficult to just look at this and tell how many different paths there are, and order becomes really important on this. As I extend it, as I try to add something to it, I put a new button on the calculator, for example, the order starts being important. So if I don't put it in exactly the right place, who knows what else I break? So yeah, and that's, by the way, that's the number of different paths to that. So there's three different ways to get around this. Functional chains, dictionary lookup, and dynamic dispatch. We're going to do a little bit of dictionary lookup, and we might get to dynamic dispatch today. But that usually ends up being the biggest thing that people take out of this review. So with a dictionary lookup, instead of having these switches in here with these different cases. What you do instead is you take that logic and turn it into data. So instead of having the switch, we put it in object where these are the keys, and then we just look it up on that object. Now we've taken all the cyclomatic complexity out, and coolest part of this is this thing that used to be full of logic is now just full of data, and there's only one path through the code. That's fucking cool. Dynamic dispatch is the exact same thing, except if we need to do more than just look something up, if we need to do some kind of operation, you do the exact same thing, except each of your keys in the object are functions, and you call those functions. But you get rid of all the cyclomatic complexity that way. Cool, so let's kind of look for some low-hanging fruit in here. So you said the buttons, yeah, these don't get used anywhere, so that's a good candidate for removal. Console log, let's get rid of that.
What was the shortcut you used to check if it was used?
So I did that, this is Vim, but I did asterisk. Asterisk takes you to every other usage of that, and then you can cycle between them.
If you're in the VS Code, it'll be a different shade of blue, and it's going to highlight like it's not used anywhere else. And then once you do use it, it'll
Dope.
be colored.
So I'm going to say, I want to refactor these to query selector also. It's going to be query selector. This is going to be query selector. Cool. Shouldn't have changed any behavior there. Another thing we can do to kind of clean this up is instead of, like, I write stuff this way too, where you just do the anonymous function in a handler and wrap all the stuff in here. But it's, as part of refactoring, I'll usually extract that out. So we can call this like load calculator. Might come up with a better name as we're working. So we can take all of the stuff in that function body and put it here. And now this becomes just that.
We had that before, and I don't remember why we changed that.
I didn't like my option.
Fine.
Also, there's no reason you can't declare a function inside of a function, but if it's not necessary, probably rip those out and bring them up to the highest level.
Yeah. We'll use that event, and it's going to be from. It's going to be past the event, so it's fine.
Well, it makes the bulk of the function body smaller, and a
Yeah.
smaller function body is easier to read, always. So, and also, like, if we were testing this, if a function is declared inside of another function, to test that, how do I get that function out? Like, if I want to run just that function on its own, I can pass it a fake event and check that certain things were called on it or whatever else. But if it's inside of something, then I need a way to get it out of that function, which means I'm returning them, or I can just yank them out. Now they're all at the top level. Okay, so already I'm starting to feel a little bit better about this. Ooh, but look at this. Oh, that's kind of interesting. So a problem we're going to run into is that I'll bet that these need to be accessible in those. I'll bet that's why
That was that.
you tucked those in, so they would still be in scope.
But those outside the function.
Not.
No, because we need to wait for, so if I do this, then it's going to do that immediately before any of it's loaded. So let's see. We could absolutely do that. And that would certainly be like the more functional way to do it.
I don't know how to do that.
So let's see. Okay, ScreenDev gets used in 3 places. Buttons div only gets used there, so this actually works. Where's 0 button get used? 0 button doesn't get used anywhere. Neither does that. All right. All right. So let's say I did want to keep it this way. Let's say I want to pass ScreenDev around. So it gets to those 3 places, and I think these 2 are in the same function. Operator clicked and number clicked. So that's each of these. So right now what's happening is we call that function with the event, just like that. So could I also just say screen too? I'll say ScreenDev, then ScreenDev and ScreenDev. All right, so if I did that right, this should all still work. 5 plus 9 equals times 9. Cool, also works. And we have significantly cleaner code. Okay, so I want to keep that that function extraction process going. So next one I see is this button event handler thing you got here. This is pretty good event delegation. Well done.
Yeah, I'm surprised that actually worked that well.
Ta-da! So now a thing you could do that would clean, well, we'll get there. So I'm going to make this a function, and we'll call it like handle button click. I don't super like that name, but let's get on there and then kind of see how it works. So then I have that handle button click. And when you do that, now this tells a little bit more of a story. When this gets clicked, handle button click. And why I don't like that name is that that doesn't feel like it's describing what's happening there quite as well. But that reads a lot better than basically any inline function. Next thing we can do to clean this up is anytime you have an if-else like this, it almost always reads better as a ternary. So if I do this, that does the same thing, but I like that it makes a little fork and it doesn't have quite as much syntax noise around it. And okay, but now this function is inside the function. So the thing that it needs to be able to do that is ScreenDev, and kind of just ScreenDev, right? So I'm going to show you a cool pattern. This is like a good one to sock away because you have to use it in React every now and then. The problem is that I want to like pass ScreenDev into this function, but what does this take? What does add event listener expect in that second argument? Anyone? What data type? Nope. A function definition, right? That's what this is. That's why that works. So I can't do something like ScreenDev. Why?
Because it'll call it right there.
Because it calls it. And now it's whatever the return value of that function is. Womp womp. So what do I do?
Make a function that calls that.
Or that returns that function definition. So What if I change handle button click to take in ScreenDev, just like I'm doing now, and the thing that it returns is a function that takes in an event like that. And now it's not dependent on any of that stuff anymore, and I can rip it out. All right, now let's see if it actually worked. 5 times 9, there we go. Let's spend some time looking at this, because the thing I did is kind of fucked. I called a function with an argument, and what that function returns is a function definition. The reason we're doing this goofy roundabout way is this function body can see both of these variables. Anybody know the word for that? There's a fancy programmer word for it. You'd say that this function is accessing ScreenDev through closure. So when I call this handle button click function, this function executes immediately. It's done. It just turns into this return value. All that's left is this. But since I have a reference to this variable that existed in this long, long ago scope, I hang on to it. I've closed over that variable. That's what a closure is. I'm going to give you a simpler example. So I have some function called outer, and it returns a function called inner. And they have these variables, and this returns A times B. And so I'd call it like outer 5, then I just invoke it again, and that turns into 25. When I invoke it, I can break that up into separate steps. So when I invoke this, I get back this function. But when I call that function that I just got back, it can see both variables. It like holds on to it. It's like a post-it note or something. And it does that because this A closed over this. So we say that inner is accessing A through closure. Cool, now ask me lots of questions about that, because that's probably one of the weirder, headier concepts that's in the program, and there's a damn good chance you'll get asked about this. Super popular interview question, what's a closure? Because it's so fucking weird and abstract, it's so hard to explain with just regular human words, that that's like the least effort an interviewer can do to like kind of get a sense of where you are. Yeah, Alexis.
So can you explain it in like a good way to
Mhm.
answer?
So my stock answer, if somebody asks what a closure is, it's when an inner scope references an outer scope after the outer scope has ended. That's my stock answer to that question. They exist in all kinds of languages, mainly functional ones. This isn't really an OOP idea. What else?
Is that how we'll ask it, or what will they say? What's the?
They'll say, what's a closure?
What's a closure?
Yep. So when an inner scope references an outer scope after the outer scope is completed. Because when I run this function here, this outer shit doesn't exist anymore. All that exists is this little inner function. Oh, I made that function keyword in there. Outer's gone as soon as it gets invoked. It's just equivalent to whatever its return value is. But like a zombie, I can still see A. More questions?
Obviously, we're using it here. Is there a pretty common situation where you would use it a lot?
Yeah, we just used it.
Okay.
That's like one of the most common ones. I have something like an event listener that's expecting a function definition. But I need that function definition to have access to another variable. So I can have it close over that and give me back the function definition. What else? Yeah.
You have to define an inner function in the outer function. You know what I'm saying?
Yes. Yes, you do.
Yeah.
That's the thing that makes it a closure.
Got it.
Cool. Now I'm going to kick it up a notch. You usually won't see it written like this. That's pretty verbose. The way you'll see it written, and like, buckle up, const outer equals A. These two things are the same.
Oh, no.
Because we can use fat arrow functions, right? So the way that you read this, when you see like a bunch of fat arrows in something, read it backwards. That's a function. B is the argument to the function, and it returns, oops, I got rid of the too many A's. B is the parameter for the function, and it returns A times B. So that's a function definition. And it's being returned by this function definition. Woof. That's functional programming.
Why is it a constant?
Because it's more popular in functional programming to not use these declared functions. These are called function expressions. These are called function declarations. There's a certain kind of asshole who really doesn't like function declarations for a not entirely illegitimate reason and does them this way. They do the same thing. The difference is that order doesn't matter with these. All of them can see all of the other ones. With these, anything that uses outer needs to come after, like you would any other variable. Woof. So I'll usually split the difference when I'm doing it, especially for these event listeners. And I'll do something like make a declared function that returns this inline function, like that. Questions about that? That one hurts. All right, onward. So let's see.
Get rid of that now, right?
This.
Number, no, wait, no.
All right, so a number got clicked. So when a number gets clicked, to first operand.
It's deciding where to print it.
Okay.
Because I've got two up top, first and second operand.
Okay.
And at the very start, it's printing the first operand. After that, it's basically.
Okay.
It's just so it does. Every time you do a new operation, everything collapses to the first operand. And then you're always writing on the second.
I'm going to come back to that one.
Okay.
It's fine. Okay, so next thing that I want to do is figure out a way to make this big case statement, how to turn that into data. So since Carl's doing a lot of operations here, that tells me that I should use dynamic dispatch. Anybody remember what the difference between that and dictionary lookup was?
Dictionary lookup was just a key, like a value, whereas dynamic was a key to a function.
Yep. So dictionary lookup, just like a dictionary. I look up a word, I get a definition. So if it's something simple like that, knock it out. Since we have a whole bunch of behavior that's happening here, kind of need to pull that out into a function. So dynamic dispatch is that same thing, just with functions. So I'll say operations is an object, and the C key is equal to a function that does all of these things. That's kind of how this works. And now if I look up something like operations at C, I get back that function and I can call it. That's fucking cool. And there's actually a shorthand for this. We can just take out the function keyword altogether and just do that. And since this is just a letter, we can leave that off too. But since we have some symbols in there, I'm going to leave them all in quotes. All right, so next one is plus. So I take all the plus stuff out. Okay. Next one is minus. Cool. Next one is X. Ah, shit. Okay. And then this, the division symbol. So I'm just going to copy that one. And then equals. Okay. So I have all of those in that object now. So I should, instead of running this switch statement, be able to do something like operations at event.target.text content. And then what I get back from that is a function that I can just call. So if I delete all of these cases, I should be able to do something like that. And anything above this? This, I'm going to try to pull out all this data from this too, but let's see if this worked. Nope, something I didn't like. Oh, it's because I still have that example down here. Cool. 5 times 9.
Oh my god.
Holy shit. Cool. So, next cool thing we can do. These are functions, right? Well, that means they can take arguments. Huh. So we have these 4 things here. What if I pass those in? Okay. So maybe I do ScreenDev first operand, second operand, 2 first operand. All right, so I grab those and I make these arguments to this function, to all of them. And now that each of those functions is pure, it doesn't have to be in this function anymore. So I can put it out here. Actually, since it can see these kind of global variables out here, I can probably even just pass that in. Okay, so those things need ScreenDev now, but I have that, so I can pass it in. That kind of took some bulk out of that function, did it not? Also, cyclomatic complexity through the floor. There's only one path to this code. I can't get the switch statements out of order. I can't forget the break keyword. So many things. Cool. So I just thought of another thing I can do. What if, I'm wondering if there's a way where for my button click, okay, so I don't have like a default case on this. So if something isn't in this list, there's like, I'm not handling that case. But if I pass something in there that wasn't one of those, what was it?
Nothing. Nil.
Think like, not like specifically the logic in this. On the calculator, if it's not one of those things, it's a number. Everything else is a number, right? So let's say I make a number function here. And what if I did something like I'm trying to look that up, and if it isn't, Let's see. What would that be? What would that fallback be? So like 9 isn't on there, so that would return something falsy. So I can have a fallback on that where I do operations at number and invoke that. Pass in, let's see. So I'll say operation is that, and then I call operation with ScreenDev. No, that's not what I do. Yeah, I got the shit. Check this out. So I check to see that if it's there, and if it is, I call it with ScreenDev. Otherwise, I call the number one and I pass in ScreenDev and event.target.text content. So it has the number. There we go. So then this number one is going to take in ScreenDev and the number. And how do I handle numbers? So that's the body for that one. And this just becomes number. This just becomes number. And it has ScreenDev. Cool. Not quite, because you're doing an assignment. So those are statements. You can't put statements in ternary clauses. But now, this doesn't matter anymore. Operator click handles all of it. So we can delete that. And I think we can do this like operator clicked thing. We can do our closure there. Shoot, do we even need the closure? Yeah, we still need the closure because it still needs that. But this turns into operator clicked. We pass in the ScreenDev, and then we return event. And we just throw all of that in there like that. And now this handle button click becomes operator clicked. Yeah. And now I think we can get a better name for this. Let's say this is like perform operation. That's a better name. So if we go back to my issue with that name before, now when any button gets clicked, perform an operation. That's a little bit better. All right, let's see if it worked. 5 minus 3. Oop, some didn't work. Operation isn't defined. Operation. Oh. Oop, I don't need this part anymore. Cool. Missing function body 85. Ah, I see it's up here. This is all right. 5 minus 3 equals All right, so let's keep looking at this. So all that's like data now. That's a lot better.
Can I ask a question?
Yeah, hit me.
Can you, I guess I'm still a little confused why the, like, data, how that replaces, like, the case switch or if then, like, isn't it still essentially doing the same thing?
No, because each of these are independent now. They don't depend on any kind of state being the case. I can test them separate from the application. I can just call operations C, I pass in some dummy div, and I can check stuff on it. So I can test the correctness of this completely separate from the application. I can't do that with just a switch statement. So if I know that this logic works, I can use this anywhere that that logic would work. If I have something that's hidden inside of conditional logic, that's what makes that brittle, is I can't test that independently from the function that it's running in.
Oh my god. Yes, oh my god.
And then at like lower levels of programming and higher levels of mathematics, we can like write this as a proof, and then anything that conforms to whatever like rules of behavior we want to say, those all work. That's kind of the core of functional programming. Dope. Let's see if there's any other low-hanging fruit in here. So plus minus, divide. There's some pretty minor differences between these. There's a lot of repeated logic.
Yes. Yeah.
So.
I couldn't think of a good way to cut it down.
So what we'd do is we'd say, what's different between them? So that.
One, the operation.
And the symbol. Well, yeah, I guess it's the operation.
Well, for the multiplication and division, there's a problem since it's moving
Yeah.
from X to star. And
So I need the symbol and I need the operation that's being performed. But other than that, that's the only thing it changes, right?
yep. Otherwise, they're identical.
Cool. So if I make that a function, math operation, something like that, and it takes in a symbol and an operator. So if I put that in here, then this becomes, is that one the symbol? Wait, no, they're the same. I might have to come back to that. Okay. So we'll say that's an operator and that's an operator. Okay. So now this should be able to be something like math operation plus. I should be able to get rid of all that other function bulk. All right. So let's see if that still works. 5 plus 6 minus 9 times 2 divided by 2. Yep, so it works. So it took quite a bit of bulk out of that also. See if there's any other super low-hanging fruit. So I guess if I were to keep going on this, the last thing that's kind of irritating me about this is not very many of these functions are pure. So math operation takes in operator, but it reads to first operand, and it does these things with first operand and second operand, even though those didn't get passed into the function. That I just smell poop face when I see that. Because now I can't test those independently. I can't just test that math operation works. I can only test that it works in an environment that has those things defined in it. It's not as good. So if I think of like other times I've tried to refactor this, let's see how I did it. That's a pretty good one. So with this one, I had the same thing. I did event delegation with buttons, and I had a screen one, and those were globally available. I made this get behavior function and predefined the operators. Did some similar stuff there.
Is that first line is the declaration? You just made a
This?
dollar sign?
Oh yeah. So I guess that's another thing I wasn't super crazy about in this one is calling it like ScreenDev, buttons div. It's all right. I don't think anybody's gonna like fire you for doing that, but
Readable. Scripted.
right. So I'm putting this inside of this dollar object so I can do something like dollar screen and dollar buttons and stuff. Makes it a little bit tighter, and it keeps all of my selectors in one data structure.
Okay. Dollar sign for any reason, or just?
It's because that's how it worked in jQuery. And so developers of a certain age kind of associate those things together. Yeah, so what I did on this, I did assign, I didn't do event delegation on this one. I actually looped through each of the buttons and then looked up their behavior and then attached separate listeners to each of them. That's a way you could do that. And then I test to see if something's a number with a regex. I forgot about that. And my best solution to this one was the React one that I did. I spent a little bit of time on this. I broke them all into components. And let's see. So I had this keypad thing, and I passed in all this shit. A lot of different ways to solve this problem. And I've done a lot of them. So let's chat a little bit. Watching that process, give me some takeaways.
Never want to use a switch case statement again.
So I'm going to modify that. Ifs and switches, they're a fine place to start. Get it working. Get to green. But before you move on, see if there's some way you can turn that logic into data, because usually you can. Cool. 4 takeaways.
I think it's really cool to see like the power of, being like this problem solved with functional programming best, or like maybe it's object oriented, something else. Once you like get that down.
Yeah.
I kind of have a question.
Yeah.
So like, is that something you do when you're refactoring it? You're like, oh, or is
a lot of programmers, myself included, will have like predilections. Mine is definitely the more functional side. And so I'm always looking for ways to keep my functions pure, and to chain stuff together, to extract out little tiny reusable pieces. That's a very functional approach to that. And somebody with like more of a bent towards OOP would go, all right, what are the nouns in this, and what verbs do I want to allow them to take? So you might have one for the keypad, you might have one for the screen, you might have one for each button. And you go, okay, so a button, is there one like set of shared behavior that all buttons have, and then they subclass into operators and numbers? And so usually, and once it gets started, refactoring something that is OOP into functional is usually just like a waste of time. And so it usually makes more sense to stay in whatever paradigm you're in. But every once in a while, and I'll give you an example of this, if you find something that can be independently extracted out of the application, so like I'm working at Health Scholars, my last job, and they have this like gnarly data transformation that they need. It doesn't have anything else to do with the app. If it's just a function that says like calendarize this, like that's fine. It could be an NPM package for all anybody gives a shit. If you can extract that out, they had this gnarly, super long procedural set of code for that. And I turned that into like a tight set of functional code. That's pretty legit. And then like I didn't need to refactor the entire application because it had such clean entry and exit points. So for something like that, data transformation like equals functional programming. It's like you don't even need to use metaphors; it's right there in front of you. So then I'll go, perhaps a paradigm I shall seek. But otherwise, I usually try to keep it in roughly the style it was written in. And a lot of times, once you've refactored that and removed a lot of the repetition, you'll go, oh, I have these really neat Legos that sort of snap together, so I can extract this piece. You'll notice that like, I didn't try to reimagine Carl's solution while I was working with this. You kind of work with what you have, and it sort of ends up going in a particular direction, which ends up being easier to turn into something else if we get to. More takeaways. What else? Yeah, Carl.
Takeaway, but can you try one thing?
Yeah.
Back on there?
Uh-huh.
Click between buttons, see what that does, if anything.
Like these two?
Like, no, like.
Change the operator?
Brace space in between.
Not the buttons, like the
on the
digits.
count.
Oh, like this?
Yeah. Nothing.
No.
That's good.
No. I don't know, you're running into problems with it at one point, but no, seems to not do it. Good.
So yeah, that's I changed your event delegation thing, which probably helped with that. This is the problem with event delegation is there's so many like elements that could be in there. You kind of have to like test for them and shit. It's gross. Cool. What else? Give me another takeaway. Yeah.
I think I've been getting into the habit of trying to make my code like as short as possible, and I kind of realized watching this that like it does like that's not the key factor. It's more like readability.
Yes. And like it gets shorter when you break out the logical pieces. You don't have to like explicitly try to make it as short as possible. You want to make it as like reusable as possible. And in that process, and looking for repetition and getting some of that stuff out, that's how code becomes like short. If you just try to like use short variable names or not have intermediary variables, like, and only that, it tends to not work as well.
What was the final line count on there? 54? Or?
67.
Alright, took up like a good 30 lines.
And like, since these kind of have this dependency on these, I couldn't actually do this, but you could do something like if I do touch operators.js, I could like extract this out into a module, and now it doesn't need to be in this file anymore. And that makes that a little bit more focused. So if I pull all of that over to here, like I said, this will break because of these things. But now I've taken all of this logic out, and now it's down to 34 lines. Because I don't need to test my data. The data's fine. I want to test behaviors, and now I've kind of focused in on that. Cool, one more takeaway.
Just going through and looking at what you actually need some more in vertical slices. The very first thing we did was just pulled out shit that wasn't even used.
Yep.
That you can, like, for instance, kind of in my code, I'm sure there's probably stuff in there that I don't use.
Oh, yeah.
Come right out immediately.
That's like student problem number one is you get nervous that like, well, what if I need to go back to this thing? And so like when I look through your code, I'll just see these like commented out graveyards or like hundreds of unused console logs or something like that. If you clean up after yourself, it gets easier to read your own code and you see your own patterns a lot more clearly. It's another reason I don't like code comments. Like, sometimes I'll do them as I'm trying to understand something, but like by the time it's time to commit, rip all that stuff out. It just makes it harder to read. Cool. Any last questions?
Can you push the refactored version of GitHub?
Tell you what, I will, well, let's see. I was gonna say, can I PR that to Carl's, but I didn't fork it first. Stupid me. Sure. So I'm going to say this is in-class refactor with Kyle. And then I'm going to go over to GitHub. And legit hub, like that. We'll call this like January DOM calc refactor. And if you've ever wondered how you do this, so I get that URL, and now I can do, if I do get remote -v, like that's what my origin is currently set to. If I do get, that's Carl's. If I do get remote set URL origin to this new one, now I can push it up to mine. And cool, there you go. And that is, you guys aren't new friends. It's please. There you go. Cool, thank you very much. You are very welcome.